Hi everyone. Welcome to our discussion today. We're diving into a crucial concept in molecular simulations, the minimum image convention. This idea helps us simulate large systems efficiently. It's a cornerstone for many scientific discoveries. Molecular simulations let us predict how atoms and molecules behave. We use computers to model these tiny particles. Imagine studying a liquid. It has countless molecules. Simulating every single one is impossible. Our simulation box is always finite. But real liquids don't have walls. They extend infinitely. This is where periodic boundary conditions come in. We imagine our simulation box as one tile in an infinite mosaic. If a molecule leaves one side, it re-enters from the opposite side. This creates a continuous, infinite-looking system. But this creates a new problem. How do molecules interact? A molecule in our central box could interact with another molecule. It could also interact with an image of that molecule in an adjacent box. And even images of images. This gets very complicated very fast. We need a simpler rule. That's the minimum image convention, or MIC. The minimum image convention simplifies these interactions. It states that each particle in our central simulation box only interacts with the closest image of every other particle. Think of it this way. For any two particles, A and B, we look at particle B in our central box. Then we look at all its images in the surrounding boxes. We pick the image of B that is nearest to particle A. Particle A only sees and interacts with that single closest image of B. This drastically reduces the number of interactions we need to calculate. It makes simulations much faster. This convention is essential for realistic simulations. It ensures that particles don't interact with themselves or with distant copies that are too far away to be relevant. It maintains the illusion of an infinite system. For the minimum image convention to work correctly, there's a vital rule. The size of our simulation box must be large enough. Specifically, the box length must be at least twice the cutoff distance for any interaction. What's a cutoff distance? It's the maximum distance at which particles are assumed to interact. Beyond this distance, we often assume interactions are negligible. If the box is too small, a particle might interact with multiple images of the same other particle within the cutoff distance. This would violate the minimum image principle. So, choosing the right box size is critical. MIC is a clever trick. It allows us to simulate macroscopic properties using a small, manageable number of particles. It's fundamental to fields like materials science, chemistry, and biology. Understanding MIC helps us interpret simulation results correctly. It's a powerful tool in computational science. Thank you for joining me today. I hope this explanation of the minimum image convention was clear and helpful. If you found this video informative, please give it a thumbs up. And don't forget to subscribe to the channel for more insights into scientific computing and molecular simulations. Your support helps us create more content like this. We appreciate you watching.